You ever stumble across something online that just stops you in your tracks? Not just a product, but something that feels more like, well, like you've peeked into a secret research lab. That's exactly what we're doing today. We're going to try and deconstruct Radical Deep Scale, an incredibly complex suite of technologies that seems to be aimed at something huge.
So the big question is, what is Radical Deep Scale, really? It's definitely not a single app you can just download and start using. No, it's an entire ecosystem of these super specialized tools that, honestly, at first glance, don't even seem related. So, our job today is to connect the dots and see if we can figure out the master plan. Okay, first piece of the puzzle, a tool called Aerial. And just look at this interface. It is dense. It's packed with bizarre acronyms and controls. The documentation says it's for modeling AI and logic, specifically for prototyping brand new kinds of computer chips called NPUs, or neural processing units. And then there's this, Arc Lake Chemistry. It looks totally different, right? It's basically a virtual laboratory. You've got options in there to simulate physics, run advanced math, and even mess around with different chemical elements. This is clearly a really powerful tool for some serious scientific simulation.
And it doesn't stop there. There are even more pieces, like this cryptology tool that has this wild 3D maze generator for creating cryptographic keys. So just to recap, we've got AI modeling, physics simulation, and secure programming, all under one umbrella. The question is, how on earth does this all fit together?
All right, let's start by digging a little deeper into the two main pillars of this whole digital world. Aerial, for modeling all that complex logic, and ArcLake, for modeling the physics of the real world. You get the feeling these two are the engines that are driving this entire system.
So, what is Aerial, really? Well, according to its own documentation, it's a tool for simulating how AI software would actually run on custom-designed hardware circuits. And it does all this live in the cloud. You can think of it like a bridge between an AI software code and the physical chip it's eventually going to live on. Now, you have to appreciate the terminology here. It is unique. I mean, LITR BRPN sounds like something straight out of a sci-fi movie, but it's actually an acronym for the core components. You've got the tripartite foundation, which is the system's core logic. The Ash buoyancy execution log. That's kind of like a black box flight recorder, tracking everything the AI is doing. And then the Ash canvas, which is a visual tool for, and I love this phrase, dependency sculpt.
Okay, let's pivot to the second core simulator, Arc Lake. This is where we make a huge shift from the world of pure logic to the actual physical world. It's a digital lab, and it seems to be designed specifically for material science. It lets you build and test molecular structures and play around with chemical compositions.
And here's what makes it so interesting. Users can simulate dynamic physics, sure, but they can also tweak these unique variables like something called the arc edge factor. This isn't just about making pretty 3D models of molecules. It's a full-blown simulation engine for inventing and testing brand new materials right from the atomic level.
So let's see, we have tools to simulate AI hardware, and we have tools to simulate new materials. This is where the whole story starts to get really, really interesting, because we're about to move from digital simulation to actual, tangible, real-world engineering.
And here is the proof. This is a real-world output. This isn't theoretical anymore. What you're looking at is a document for something called a Hercules alloy, and it has a very precise chemical recipe, 60% aluminum, 30% titanium, and so on. This is a material that was clearly designed in that virtual lab for a very specific purpose.
And if you're wondering what that purpose is, well, they spell it out for you. In another document for a different alloy, we get this direct quote. The goal is to have tungsten and nickel as the abundant result material for use in the hypersonic engine design. Yep, all this incredibly complex simulation, it has a crystal clear and frankly, unbelievably ambitious goal, building parts for hypersonic engines.
But hold on, because it gets even deeper. A project called Dovetail adds yet another layer to all of this, augmented reality. The whole idea here is to take the digital models that were created in Aerial and ArcLake and literally overlay them onto the physical world. It's all about bridging that gap between the digital design and the physical manufacturing.
So, we've got AI simulation, material science, custom alloys for hypersonic engines, and AR integration. It's all happening under this Radical Deep Scale name. But it turns out there's one other name that finally ties this entire thing together into a single unified vision, Dart Meadow.
I know, it really feels like this is just a collection of separate, crazy ambitious projects. But after a little bit of digital digging, it becomes obvious that they are all directly connected. They all point to a single company with a single mission. And the clue? Well, it's been hidden in plain sight this whole time, in the one place nobody ever thinks to look, the legal fine print. If you go to the Radical DeepScale website, you have to agree to a privacy policy. And whose policy is it? Dart Meadow LLC. Legally speaking, the two are one and the same.
So what exactly is Dart Meadow? A quick trip over to their GitHub profile gives us the final, totally unambiguous answer. The description is simple, it's direct: Dart Meadow, aerospace tooling and engineering.
And now, finally, we can step back and see the entire blueprint. Radical DeepScale isn't just some random collection of cool software. It is a completely cohesive, vertically integrated pipeline for one of the most advanced fields of engineering on the planet.
So here's how the entire process works, from start to finish. You begin in Aerial, where you model the complex AI systems. Then, you hop over to Arc Lake to digitally invent the exact alloys you need to withstand extreme conditions. Then you engineer those materials, and finally, you use all of it to build the actual aerospace hardware. It's an incredible workflow.
So, what are the main things you need to take away from all this? First, Radical DeepScale is an entire ecosystem, not just a single product. Second, it's designed to directly connect the world of AI simulation with materials science. Its ultimate focus is on advanced aerospace, specifically hypersonic engineering. And finally, it represents a complete, full-stack approach, all the way from a line of code to a physical, flight-ready piece of hardware.
I mean, it is an absolutely incredible, ambitious vision to build the future of aerospace literally from the atom up. And it leaves us with this one big, thought-provoking question. By creating a perfect digital twin for everything, from an AI's logic all the way to an engine's alloy, what kind of future is Radical DeepScale actually building?